Yeah, hi, and happy Equinox Day. Uh, Everybody has calendars and stuff, is always in a hurry, and most people don't even know why. They're just in a hurry. And there are cycles within cycles, many cycles are going on at the same time. And here are some astrological time cycles. And I will show you a part of this video. I recommend it to everyone to at least watch it once. There's so much stuff in that, and like how it was once that we had 360 days in a year, and there was 5 days off, and all these kind of things, and the cycles of the sun, and one of those is probably to unfold right now, which is a 12,000 year cycle, which is the half of that. A great year, the half of a great year. And yes, tomorrow, yeah, last year, we entered the age of Aquarius. Basically, officially, they're not all planets yet involved in being in the age of Aquarius, but as far as I remember, it was Jupiter and Saturn. And it was last year, 21st December, Equinox Day. And here is soon Equinox Day. Let's just have a listen to what he has to say. Is Randall Carson, his name, I don't remember correctly, but you will figure out over to the link below to that video. But let's have a listen first.
Over and over again, simply raised to different orders of magnitude. Okay. This is just a little graphic that depicts this processional motion that I'm talking about here. This motion right here that is generally assumed by most astronomers to be primarily induced onto the Earth by the moon, secondarily by the sun, and then also a contributing factor by the planets. So it's almost, you could almost think of this processional motion of the Earth's axis as being the vectoral summation of all the gravity forces of the solar system acting on the Earth, causing it acting. See, when the planet rotates on its axis, and this is a critical factor, as it rotates on its axis, it spreads out towards the middle. Its equatorial diameter is greater than its polar diameter. And that, in fact, is critical to the Earth maintaining axial stability so that it's not doing this in its orbit around the sun. Because if it was doing that, it's likely that higher life would have never evolved in the first place. But due to the fact that it spins, it spreads out so that the diameter of the equator is 26 miles greater than the diameter of the pole. The sum total of all the gravity forces impinging upon the Earth from moon, sun, and planets acts upon that bulge as if it was a flywheel and is actually pulling it around. And it's that leads to the great year. And what it does is over a period of half the great year, 1 million or 12,960 years, is it reverses the seasons. So that if we were able to jump in a time machine and go back 12,960 or ahead 12,960, we would find that everything was reversed. If we would keep the same Gregorian calendar in place, the seasons would have been reversed so that winter would be July and summer would be. In fact, and then what we would see is that hemispherically, like we know that when it's winter in the northern hemisphere, it's summer in the southern hemisphere. Well, those seasons would be reversed. They flip. It's a back and forth. It's an oscillation between the two hemispheres of the Earth over a period of 12,960 years. This shows the wheel of the great year with all of the ages, the astrological months as they're known. And if we were to place ourselves right at this position right here where it says 0 years BP. BP means before present. And it also is 25,920 years. So what has been happening is that the vernal equinox, a hypothetical point in space occupied by the sun, when day and night are the exact same duration, that vernal point is moving through space as a result of this axial motion of the Earth.
Okay, I missed. So now I forgot to push a button because I wanted to pause it. You and I and everyone else is approximately here. At the beginning of the age of Aquarius. This is Aquarius. On the other side, we have the lion. And this is basically winter. Oh, I forgot a whole letter. Winter. And that's summer. It's somehow like an equinox on top of an equinox. And he's talking about the gravitational forces and all these kind of things. I don't personally cannot really agree with that, since like it might work differently. There's no such great things as gravitational forces, basically. And I was thinking about like this 360 days thing, those 5 days, which are somehow don't fit anywhere. And I thought it could relate to this. A day is not exactly 24 hours. Exact day length to day 23 hours, 59 minutes, and 59.9995505 seconds. It's 0.4495 milliseconds faster or shorter than the previous day. And the thing is, like, for example, solar flares, they can really act on Earth's spin. And gravity is tied to electric forces. And is it possible that the days have just, or the years have got longer? 5 days? Why not? Could be possible. So they just figured out that probably time is speeding up every now and then. Maybe it will slow down too. I don't know. And I just thought I want to say a few words about equinox days, special equinoxes we are experiencing. We have even a comet Leonard. And somehow it would be really interesting if there would be any kind of footage or measurements or whatever kind of stuff you would get data from the path where it's flying and its interaction with the magnetic fields, for example, other planets like Earth. How is there any interference going on with that? Does it do anything, or is it too small? Like, is there anything going on? And if you read somehow like old history or something, there has been many times a comet in the sky and something happened on Earth. Someone got born, or there were plagues and everybody died, and these kind of things. Throughout history of mankind, comets haven't been a good sign somehow. People know to fear them, even though probably the real reason why has been forgotten. Like, for example, the possibility that there could be some kind of whatever stuff coming from the planet, from the comet, and fertilizes another planet or something. In a way, with whatever life, bugs are life too. Probably you guess what I mean with bugs, but if you bugs, space bugs. Yeah, I leave it here. There would be so many other things to tell, like about why the Earth axis is wobbling, large low shear velocity zones, and these kind of tennis racket theorem. You can find videos about that. It's really interesting. Rotation de corps? Probably. Yeah, I leave a link to that too. And if you get what's going on with this tennis racket, and if you picture the Earth and the large low shear velocity zones, things like that, it's not only those, but it's somehow like the Earth is not a perfectly round-shaped ball, which has its mass contributed evenly over the whole surface. And a huge portion of the surface of our planet is water, which is somehow agile. It will move quite easily. It moves easier than mountains. And it reacts also differently to electric forces and these kind of things. But I leave it here. Happy Equinox Day, everyone. Thanks. Bye.